These next type of problems are called projectile problems, and in each of these problems, they'll actually give you a formula with some variables in it, usually an s and a t, and you've just got to decide by reading the problem carefully which variable you're trying to find and which variable you know. So let's read the problem. If a projectile is launched vertically upward from the ground with an initial velocity of 100 feet per second, neglecting air resistance, its height s in feet above the ground t seconds after projection is given by this formula. S is equal to negative 16t squared plus 100t. Now remember, t is time, it stands for seconds. S is the height above the ground. So let's look at the question. After how many seconds will the projectile be 50 feet above the ground? 50 feet is what? Is that the S or the T? Well, it's the S because it's feet, and we're looking for seconds. So we're going to take that 50 and put it right here. So 50 is equal to negative 16t squared plus 100t. All right, this is a quadratic equation, so we need to put it in standard form. That means we've got to get everything on one side equal to 0. Let's move all this to the other side. So we'll move this over here, and we'll move this over here, and we'll have 16t squared minus 100t plus 50 is equal to 0. Quadratic equation, put it in your quadratic formula. A is 16, B is negative 100, C is 50, and let's see what T is going to be. All right, finding my quadratic formula. Here it is. A is 16, B is negative 100, and C is 50. It's an application problem, so let's go all the way to the end and we get these decimals. I've got two answers. Let's go to two decimals. So T is 0.55 or T is 5.7. All right, we got two answers. Neither of them are negative. They're both positive. Do they both make sense? Remember the process. Do they both make sense? Well, let's think about it. We're shooting a projectile up in the air. If you take something and you throw it up in the air, it's going to go up and then it's going to come back down and hit the ground. There are two times that this will be 50 feet above the ground. One time on the way up and one time on the way down. So both of these make sense, and our answers would be 0.55 seconds and 5.7 seconds. There are two answers. All right, for the second part of the problem, how long will it take for the projectile to return to the ground? All right, well, back to this drawing. It starts up here and it's coming back and it hits the ground right here. The formula that we've got to use is this one. Negative 16t squared plus 100t equals to s. S is the height above the ground. When this projectile hits the ground, how high is it? Well, when it hits the ground, the height has got to be 0 because it's on the ground. So we're going to put 0 in for s. So 0 is equal to negative 16t squared plus 100t. This can be put in your quadratic formula, or you could try to factor it if you want to use your quadratic formula. Think about what your A, your B, and your C are. Your A is negative 16. Your B is 100. Your C, your constant, is 0 because it's not written there. So when you put this into your calculator in your quadratic formula, A is negative 16, B is 100, and C is 0. And we get two answers again. We get 6.25 and we got 0. Again, two answers, do they make sense? Yes, it starts on the ground, it finishes on the ground, but what they want to know is how long will it take for it to return to the ground? When it returns to the ground, it has been traveling 6.25 seconds. So the answer is 6.25 seconds. And remember, if your projectile is on the ground, its height is 0. So now it would be a good idea for you to stop and work problem 43 from your book.